Dear friends, I hope that you understood the first problem on Z transform, which is a raised to n un, which was a sequence which was from right-handed sequence, which was starting from 0 and ending to minus infinity. Now I will be taking a sequence which is left-sided sequence, so which will be starting from minus 1 and going down to minus infinity. So such a sequence, what is the status of Z transform, whether Z transform exists or not. So my question before the new problem is, can we have same Z transform for two different sequences? Yes, Z transform of two different sequences can be same. Only thing is that ROC can be different. It is possible. So I am taking that example only. So if I take example x of n equal to minus a raised to n u of minus n minus 1, here Z transform is equal to 1 divided by 1 minus a Z inverse, which is like the Z transform of a raised to n un. So we can have Z transform of two different sequences is one Z transform, but their ROC is different. For two different sequences there can be same Z transform. Mind well, ROCs are different. ROCs are to be different, right? So by answering this question, let us start the problem which is for anti-causal sequence. The first sequence was causal sequence. Causal sequence means sequence which is starting from 0, and anti-causal means it is starting before 0. So anti-causal sequence we are going to consider, and we are trying to find the Z transform and what is the effect of anti-causal sequence on the ROC of the Z transform. So x of n is equal to a raised to n u of minus n minus 1. So u of minus n minus 1, just put n equal to minus 1. What happens? N equal to minus 1, it becomes u0. N equal to minus 2, it becomes u1. So and n equal to 0, it becomes u of minus 1, which is 0. It is 1 only when n is less than equal to minus 1. Minus 1 less than equal to minus 1 means what? What is less than minus 1? Minus 2, minus 3, minus 4, minus infinity. So since n is less than equal to minus 1, the sequence x of n is existing, so we have to cover that much portion while finding the Z transform. Otherwise the result is 0. u of minus n minus 1 is 0. It is a anti-causal sequence. X of n is a anti-causal sequence. Anti-causal sequence. In earlier problem the sequence was a raised to n un, which was causal sequence. So here anti-causal sequence, what happens to ROC when the given sequence is anti-causal? Let us find that. So let us find the Z transform of sequence x of n a raised to u of minus n minus 1. Remember the limit is minus 1 to minus infinity. So here limit of the summation is n equal to minus 1 to minus infinity. So here first you should write lower limit here and upper limit here. So and here minus sign is also there, remember. So minus a raised to n, I have taken everything into account. So Z raised to minus n, u of n minus n minus 1 is taken into account, or otherwise you take one more step. So those who are new to this unit step sequences, so may be facing problem. So summation x of n Z raised to minus n equal to minus infinity to 0. So minus infinity to plus infinity. X of n is given minus a raised to n u of minus n minus 1 Z raised to minus n equal to minus infinity to plus infinity. It is as per the definition of Z transform. Now limit has to be changed according to this. So it is existing from minus 1 and going down to minus infinity. So we can say it is n equal to minus infinity to minus 1, minus sign you can pull out, a raised to n Z raised to minus n. So this is what we are getting here, that is x of z. Now we have to play with this to get the result in the standard form. So replace n by minus n, replace n by minus n, n by minus n. So what we get? Minus summation a raised to minus n Z raised to plus n. and limit will be what? N equal to plus infinity, n equal to 1 to plus infinity. So x of z, let us, so limit n becomes plus infinity, so plus infinity will come at the top, minus 1 becomes plus 1, it becomes, it will come at the beginning. So this is the equation which we want to evaluate. So limit is from 1 to infinity, so we want limit from 0 to infinity to use the standard results in the mathematics. So let us consider what is n equal to, if I take n equal to 0, what is the result? N equal to 0, the result is minus 1, right? N equal to 0, it will be a raised to 0, a raised to 0 is 1, z raised to 0, that is also 1. So n equal to 0, it is contributing, giving me minus 1. So what I can do is, to take n equal to 0, what I have to do is a inverse z raised to n, and here I am taking minus 1 additional, so I have to do plus 1. So this is because I started from 0, because of 0 it is giving minus 1, and that minus 1 is not there, so add plus 1, minus 1 plus 1 get cancelled, because okay, and we get the closed formula which can be solved by using the result in the mathematics. So here now we can write this, we can consider this is alpha, so alpha should be less than 1, so minus 1 divided by 1 minus, a minus sign is this, 1 minus a inverse z plus 1, provided, this is very important, a inverse z must be less than 1. So this is ROC, region of convergence. Z transform exists and value of Z transform is this, but that is the value only when this is satisfied. So it is nothing but mod of Z divided by mod of A, right? So less than 1, so which is telling that mod of Z is less than mod of A. So Z transform exists only when mod Z is less than A. So Z transform exists if Z is taking all values which are inside the circle of radius A. So this is telling that, which implying that mod Z less than mod A. Earlier problem the mod Z was greater than mod A. Now in this problem, since the sequence is anticausal sequence is left-sided sequence, so here it is anticausal sequence going down to minus infinity, sequence is going down to minus infinity, so it is a left-sided sequence. So in this case your ROC is inside the circle of radius A. So before plotting the ROC, I will just simplify this. It will be, let us multiply this with 1, so minus 1 multiplied by 1 means 1 minus A inverse Z divided by 1 minus A inverse Z. Your ROC is as it is, please keep in mind that Z is less than A. So minus 1 and plus 1 is cancelled, so now what we are having, A inverse Z divided by 1 minus A inverse Z, right? So divide both the side by A inverse Z. So what happens, just see, minus A inverse Z rather, so minus A inverse Z you get here 1, here it is divided by that minus A inverse, so minus A inverse it becomes minus A inverse Z inverse 1 divided by, so here also I am dividing by minus A inverse Z, so 1 divided by minus A inverse Z becomes A Z inverse, and here it get cancelled, so plus 1. Okay, so your result is 1 divided by 1 minus A Z inverse, which can also be written as Z divided by Z minus A, provided, that is very important, Z should be less than mod of A. Z should be less than mod of A. Z transform exists, right, only when your ROC is, so ROC is interior to circle of radius A. So let us plot the ROC. So this is my Z plane, this is imaginary axis of Z plane, real axis of Z plane, and here I am saying it is a radius A, circle of radius A, so your ROC is this region. This is your ROC. These are the values of Z for which Z transform existing. So this is ROC. Values of Z for which Z transform exist. That region is called region of convergence. So I told you that in earlier case it was a causal sequence. The ROC was outside and it is anti-causal sequence, so ROC is inside the circle of radius A. So both the cases x of n, both the cases a raised to n un, that was first problem, and second problem minus a raised to n u of minus n minus 1. Here the transform is 1 over 1 minus a z inverse. Transform is same, but here ROC is different. ROC is Z is greater than mod A, and here ROC is different, Z is less than mod A. That is why I am telling you ROC is very important. Whenever you are finding the Z transform, you have to make a mention of ROC. So ROC is interior to the circle when sequence is anti-causal, and ROC is exterior to the circle when sequence is causal. So anti-causal, so what is that? ROC is interior, and causal sequence the ROC is exterior to the circle. Whatever circle, a raised to n un. A is 2 outside the circle of radius 2. A is, let us say, 5, it is outside the circle of radius 5. And here suppose problem is minus 5 raised to n u of minus n minus 1. The Z transform is 1 divided by 1 minus 5 Z inverse, but here ROC is inside the circle of radius 5. So instead of solving multiple problems on the Z transform, you remember these two formulas. A raised to n un, what is the Z transform? 1 divided by 1 minus a Z inverse, and ROC is exterior to circle of radius A. And another problem is x of n equal to minus a raised to n u of minus n minus 1. This is an anti-causal sequence. For anti-causal sequence, Z transform is always inside the circle of radius A. So a raised to n un and minus a raised to n un minus n minus 1 minus a raised to n u of minus n minus 1. In both the cases we have seen, we found that Z transform is same, but what is different? ROC is different. So after having both these problems at our hand, let us see that what is the Z transform of this problem. Let us say 2 raised to n un, and here minus 3 raised to n u of minus n minus 1. If I am finding the Z transform here, let us consider that this is first one is x1 n, second one is x2 n, because we are not yet seen the linearity property. So we will find Z transform of the first part, x1 n is equal to 2 raised to n un. So and second, x2 n is equal to minus 3 raised to n u of minus n minus 1. So here we know that x1 of Z, what is x1 of Z? x1 of Z is nothing but 1 divided by 1 minus 2 Z inverse, provided Z should be greater than 2. And here second case Z transform is again 1 divided by 1 minus 3 Z inverse, but it is telling that mod Z should be less than 3. So here this part is saying Z should be greater than 2, and this part is saying Z should be less than 2. So here we are having circle of radius 2 and circle of radius 3. One is telling Z should be greater than 2, other is telling Z should be less than 3. This is circle of radius 3, this is circle of radius 2. So ROC in this case is this is your ROC, because writing the Z transform of x of n, we have to consider ROC of this part and ROC of this part. So common region which is satisfied by both, one is telling greater than 2, other is telling less than 3. So ROC is this portion is called ROC, region of convergence. So once we know that a raised to n un and minus a raised to n u of minus n, these two Z transform and their ROCs, we can solve any problem on the Z transform. Algebraic manipulations are very easy in Z transform, and because of that many times we find Fourier transform by using Z transform, do all calculation in Z domain, and again convert that Z transform into Fourier transform for a signal for which Fourier transform exists. So Z transform manipulations, calculations, those are very easy compared to Fourier transform, because we have discrete Fourier transform and discrete for analysis of discrete time signals. Likewise, Z transform is also doing analysis. We prefer Z transform many times because of requirement of calculations required or manipulations required in Z transform. They are less, or manipulations are easier compared to manipulations in the Fourier transform. Here we have completed definition of Z transform, then Z transform of signal a raised to n un, Z transform of signal minus a raised to n u of minus n minus 1. If signal is anti-causal, Z transform is inside the circle, and signal is causal, it is outside the circle. Z transform is easier for algebraic manipulation compared to Fourier transform, so we use Z transform many times while solving the problems of Fourier transform for which Fourier transform exists. The requirement of existence of Z transform here compared to Fourier transform is different. What requirement here is summation mod of x of n r raised to minus n. That summation should be less than infinity. So because of r raised to minus n, we are having wide range of signals for which Z transform is possible, and corresponding Fourier transform does not exist. So while I told you that while writing or while solving the problem, you have to find out the Z transform, and also we have to mention ROC. So ROC is very important as far as Z transform is concerned. So for every problem while solving Z transform, please specify ROC. Let us see one simple example which you can understand easily. If I take x of n is equal to del n, x of n is equal to del of n. So we know that del of n is a signal, or it is a standard signal in digital signal processing whose value is 1 at n equal to 0 and value is 0 otherwise. So del n is a signal, or it is a, we can say, one sample or unit sample. We can say it is a unit sample signal having unit sample. So its amplitude is 1 at n equal to 0, otherwise it is 0. So what is the Z transform of such a signal? So x of z is equal to x of n z raised to minus n. So here del n, so limits of the summation here minus infinity to plus infinity, but here only n is equal to 0 Z transform is possible, because del n is existing for n equal to 0 only. So n equal to 0, this is 1, n equal to 0, this is also 1. So Z transform x of z is existing, right? X of z is 1, whatever may be value of z, answer is 1. So Z transform doesn't depend on value of z. So your ROC is entire Z plane. So all values of Z transform exist. So all entire region for which we have drawn Z plane. So everything on the Z plane, the Z transform exists, because x of z equal to 1, where z is independent of 1. 1 is independent of z.